All right, welcome back to Mr. P Helps with Calculus. This is Unit 0, day number 10, and we're going to be solving logarithmic equations. And we're going to start off here with some exponentials, which it's what we did in the last video. So we can make both of these base 2. 32 is really 2 to the 5th power, 2, 4, 8, 16, 32. So that's 2 to the 5th. And then raised to the x power, and 2 to the 16th is really 2 to the 4th, which is raised to the 1 minus x power. Now, power to a power rule states that whenever you raise a power to another power, you multiply those powers. And before we even do that, since the bases are set equal to each other, then we know that the exponents must also be equal to each other. So that's 5x equals 4 times 1 is 4, so we have to distribute, and then 4 times negative x is negative 4x. Now from here, I can combine the like terms. That's going to give me 9x equals 4, and it looks like the answer is going to be 4/9 when I divide both sides by 9. All right, so now over here, we can make both of these base 2. So 2 to the negative first, because remember, negative exponent flips it to its reciprocal, to the 3x minus 6 power, and that's equal to 2 to the third and x plus 1 power. Bases cancel each other out, so that becomes negative 3x plus 6, and that is going to equal 3x plus 3. Now, add 3x to both sides, and you get 6x, and if I subtract 3 from both sides, I get 3. Divide both sides by 6, and it looks like the answer is 1/2. All right, so now we just did some exponential equations, and we're going to be tying that to logarithmic. Now, logarithmics are the inverse of exponentials. Whenever you say log, it's basically like saying what power. So when this says evaluate, this says what power of 2 is 8, and that would be 3. 2 to the third power is 8, and you'll see how I'm going to write this later on, but this is literally saying 2 to the third power is 8. What power of 5 is 625? Now, 525, 125, 625, so it's 4th power, which is the same thing as 5 to the 4th power equals 625. This is common base, which is base 10. Anytime you see no number down here for logarithms, then you know that it's base 10. So 10 to the 2nd power is 100. 3 to the, okay, I'm going to have to work this one out. 3, 9, 27, 81. 81 times 3 is like 271, I want to say, and then it must be 729. So it looks like it's to the 6th power. All right, so now it says write in the log form. So now I'm doing it backwards. So this is log base 2 of 256 is 8. 2 to the 8th power is 256. That is, 256 is called the argument. It's the number that's inside of the parentheses for a log. So this would be log base 4 of 1024 equals 5. 4 to the 5th power is this. Here we have log of 1000 is 3. And there we have log base 1/3 of 1/9 is 2. All right, so moving right along, we have write in exponential form. So this is helpful because it's going to help us solve the equations. So if we can rewrite these logs into exponents. So I'm only going to do a couple of these. I know I did this on the last page. This is 3 to the 4th equals 81. Or this is 10 to the 0th equals 1. This is 1/2. I know I said I would only do a few, but they're so quick, I was able to do them pretty fast. All right, now, solving for x. So in this case, 5 to the x power is 25. And then if I'm trying to solve for x, I'm trying to figure out what x is. I'm going to change them both to base 5. This is really 5 squared, so therefore x must be 2 because the base is canceled out. For this one, we have 1/2 to the negative 5th equals x. 1/2, remember, flipped because it's negative, becomes really 2 to the 5th. So 2, 4, 8, 16, 32. So it looks like x is 32. For this one, we have x to the 3rd power is 64. So all you have to do is do cubic root of both sides, and that would be positive 4. Not negative 4, because remember it's cubic roots. So negative times negative wouldn't be a positive. Wouldn't work. And 3 to the x power is 181st. So change them both to base 3. 3 to the negative because it's 181st. So 3, 9, 27, 81. Yeah, that sounds right. So 4 power, so x must be 4. All right, so last thing we're going to talk about is how to condense and expand log functions. So anytime you have addition when you have the exact same base, all you have to do is multiply the argument. So this is really an argument of 8 times 4. So this is really log base 2 of 32. When it's subtraction, it's going to be divide. So this is really log base 4. And keep in mind, you can only do this when they're the same bases. You can't do it otherwise. So that would be 80 over 5. So all you'd have to do is divide. So that turns into 13. No, 16. Sorry, 16. That'd be log base 4 of 16. Oh, you know what? And that answer is 2, right? Because 4 to the second power is 16. For this one, we have 36 to the 5th power. Okay, so this is really 5 could be put out to the front, but I'm not going to get into that. So what I'm going to do, and I know there's a couple ways you could do this, I'm going to set it equal to x, and I'm going to say 6 to the x power equals 36 to the 5th. And then I'm going to change this to base 6, sorry. And then we have the same bases. So the bases cancel, and you're left with x equals 2 times 5, which is 10. So answer's 10. All right. Write as a single logarithm. So now we're going to take this and we are going to condense it down into 1. So this is log base 2 of 14x, because when it's addition, you just simply multiply them. This is log base 3 of p times q times r divided by s, because that's division, because it's subtraction, all with the same base. Here we have, okay, so expanding. So this will be the exact same thing I just did, only I'm going to make it larger. So that's log base 7 of x, plus log base 7 of y, and then minus log base 7 of z. All right, and this is log of 10 plus log of y. All right, and that looks like to be the end. So thank you again for watching, and have a wonderful day.